Unit 6, Lesson 1, Video 4, Permutations, Area of Focus number 2. Now permutations and the counting principle are very similar, and one would even consider them to be the same thing. But permutations do something special. Permutations use the total, find the total number of ways, which is just like the counting principle, and puts it in an arrangement, which is very common, but you use all choices. And that's how we're going to distinguish the two. Okay, so for example, we have seating 8 students in 8 seats in the front row of a school auditorium. So before, with counting principle, we said, well, we're going to have 8 people, and we're going to give awards to the top 3. That's truncated, so you only have 3 stages. But with a permutation, your stage will go all the way till everyone is chosen. So for example, if you consider a track meet, track meets have top 3 or top 4 ribbon getters. But if you go to true team, everyone gets a point, or a certain number of points based on their placement. So everyone is going to be given something. So there's a difference there between the permutation and a counting principle in that way. However, solving it is the same. It means multiplication. That has not changed. And that's going to be, you can look at that in the how-to videos if you're interested in actually calculating them. But if we want to look at this one in terms of a counting principle scenario, you're looking at 8 stages. And the uniqueness here also is that with permutations, it is dependent all the time. So you would have 8 people in the first stage, okay, in one seat, and then you'd have 7 in the next one, and then you would have 6 people in the next one, and you go all the way down till you're down to your last person. You don't go to 0 because there's none left. Again, it is multiplication, and that will be covered later if you're interested. And the product is your number of arrangements. Now, this symbol right here is also a way to show a permutation, and in that case, it would be represented as 8 factorial, which means 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, stopping there. Example 2 here is an arrangement of letters in the word rhombus. So how do you find, and again, arrangement is a key here to look for to decide if it's a permutation or a counting principle. Arrangement usually is a permutation. But again, all the letters in the word rhombus rearranged in an arrangement is a permutation. You just have to look at it as how many letters are there? 1, 2, 3, 4, 5, 6, 7. So you would have 7 stages. And you would write this one as 7 factorial. As I mentioned earlier, with a track example, true team track competitions give out points to all competitors in every event. And I should have a T here for event. In how many ways? Now this sounds like a counting principle question, but you have to read the question a little more carefully. Can all 12 runners in the event be awarded? So all of them are going to be taken care of. Now if I said the top 3, that would be a counting principle. But since all runners are going to be given something, it turns into a permutation. So there are 12 stages in which the first stage has 12 runners possible for that first spot. Then you'd have 11 people, and then you'd continue that down until you have 1. And permutation notation would say that this is basically 12 factorial. And this ends Unit 6, Lesson 1, Video 4.